Hello everyone, welcome back to my 100 most popular algorithm series. So in this particular video, we are going to play, not actually play, we are going to build the logic for Sudoku. So it's a famous game of the numbers. I'm sure many of you might have played this game. So what we are required to do here is we have given a Sudoku board with few numbers filled, and we need to basically check the validity of the board as it stands right now. Okay, so all the elements, we need to make sure that they are at the correct position. So just quickly reiterating the rules of the Sudoku. So in Sudoku, each row must contain unique digits, each column must contain unique digits, and each little grid, this 9 cross this 3 cross 3, this 9 cell smaller square should also contain all the unique digits. So that's the rule of the Sudoku. So the way we are going to solve this is we'll have like a we'll have a helper function, okay, which will validate every cell. So this function we will keep on calling for every cell, and will pass board, row and column. So this helper function will be passed a cell, and this function will check whether that particular number on that cell is placed correctly or not. So it will check if there is no other element on this row should be 5, and no other element or in this particular column should be 5, and no other element in this particular little square grid should also be 5. So that three things this function will check, and our parent function will basically call this helper function for all the numbers that are present on the board. So that's how we're going to approach this problem. So first let's write the logic of the parent function. So as always, we need to make sure the inputs are valid. So if the board is not present, or we do not have any rows, or we do not have any columns, then we'll simply return false. Okay, so the next task is we need to iterate to every cell of this board, and for all the numbers that are present we need to call the validate function. So as you all know, this is a grid, so we need two for loops, one for the row and one for the column. Okay, now the first thing first, we need to make sure that for all empty cells we just skip over the rest of the logic, right? We don't really care about doing anything if that particular cell is empty. So we'll just quickly make that check. So as you can see, there is dot present in the array if the cell is empty. So we'll just make that check, and we'll skip over the rest of the logic. Okay, now for every number that we found here, we'll basically have to call this. So I'll just call this function. I'll pass the board, I'll pass row and columns. Okay, now if this function returns false, which means if this cell is invalid, then the whole Sudoku, the whole board is invalid in that sense, right? So we'll just return false. So our work is done. Okay, otherwise we'll just continue for the rest of the iterations. Continue for the rest of the cells. Then when the whole board is scanned and no cell is false, no cell is invalid, in that case we'll return true, meaning the board is valid. So yeah, that's pretty much what we need to do here in the main function. So let's turn our attention to the helper function. So in this case, as I mentioned, we need to check these three conditions, all three conditions that I mentioned here. So first is we'll do the check, check for row, then check for column, and then check for subgrid. Okay. Subgrid is basically this smaller 3 cross 3 grid. Okay, so what we need to do here is we need to basically iterate whichever the cell that is given to us, Okay, first thing first, I'll just store the value of the current cell item here, so that I don't have to refer it like this every time. So that's you can even call it cell value. Okay, now what we need to do is, let's say we are given 5 as a cell, so we need to iterate to all the elements in this row, and then we need to make sure there are no more 5s here. Okay, so that is something that we are going to do. So here we will have to, so essentially in this row we need to check every column. Okay, so we need to iterate this many times, and then what we need to do is, if board, right, the row is the one that is passed and the column is this, right? So in this, the row is the one that is passed to us, but column will change, right? So in every iteration we are basically changing the column. So if that is equal to the cell value, and so if we have spotted this, let's say if we have spotted another 5 here, we need to just make sure that we are not spotting the same element, like that would be silly. So we need to make sure that the I is not equal to the row that we are traversing. So basically I should not be equal to the column. Yeah, the I should not be equal to the column that we are currently sitting, right? Because that is the current element. So you don't want to really compare that. If we found another value which is equal to cell value, and that is at a different location to our current element, then we know for sure that the board is invalid. So we return false. Right. So that was for the row. Now the same thing, pretty much similar, we need to do further to check for any other existence of 5 in this particular column. So for that we need to do this iteration. So if the board, now here the column, like the row is changing, right? So column is fixed, but the row items are changing, so that is being referred here as I, and the column is fixed. If this board cell of any of the cell matches this, and right, if we found another 5 here and that is not equal to the position that we are currently at, then we know for sure that the board is invalid. So that's it. That's the second check. Now for the last part, that's a little bit tricky one. We need to first spot which subgrid that we are in, right? So basically there are 9 subgrids, as you can see. Right. Okay, we need to make sure on which subgrids we are there. So I'll just call subgrid start index. Okay, so we need to, let's say if we are in this subgrid, we need to have the start index like this. This is our start index for the row. This is the start index for the column. Let's say if we are in this middle subgrid, then the start index is this, like a row start index is this, and the column start index is this. So that's what we are trying to figure out here. So here what we'll do is, to figure out the subgrid start index, we'll take the row. Let's say for example we are here. Okay, so we'll take that row. Let's say we are in the 4th row. So that is the 4th. Now we divide it by 3. So that will become 1. Okay, so we know that we are in the, let's say we are talking about the row, we are in the first subgrid, I mean index 1, which means second subgrid, but 0 1. So we are in the second subgrid. So that, and then into 3, because we will skip over the elements that are prior to that. So basically we need to find 4th index, I mean the start of the subgrid. We need to find a row which represents the start of this subgrid. So that is what we have done here. And similarly for the column, we just have to repeat the same logic. Oops. Actually I need to row index, I'll just call it column index. Okay, so same thing for column. Let's say we are in this subgrid, last one. Okay, so we know that that's a 3rd column. So let's say let's say our cell number was 3. Okay, 3 in column wise it is at the 9th location. So if we do 9 by 3, which is 3, and then so we need to spot, so that would be here 3, and then we oops, sorry, I missed something. Yeah, okay, this is a 0 based cell. So we are at this, let's say if we were at this cell, now column wise, because it's a 0 based index, this is the 8th column. So we divide 8 by 3, which we get that as 2 because I'm stripping away all the decimal points. So I'm getting 2, and then I'm multiplying by 3, which means 6. So basically I need this start index, which is this start column. I need this subgrid where is the starting column, which is 6th. So that is this. Okay. So once we have the starting position of our subgrid, like the starting row and starting column of subgrid, we need to basically then traverse through all the elements in this in order to make a comparison. So I'll again need 2 for loops. The first will start from this and will end 3 positions later. This is for the row, and then we need another for the column, which will start with this column and end it 3 columns later. Okay. So basically this 2 for loops will help us check every element, every cell of that subgrid. Now as far as our check is concerned, we need to basically check if the element that is sitting there at that location, if that is equal to cell value. So if you found an element which is equal to the cell value that we are at, and I not equal to row and j not equal to column, okay, which means that we are not okay. So we have spotted the element, let's say here in the subgrid we have spotted 5, but we need to make sure that we are not checking the same element incidentally, right? So that is these 2 conditions will make sure that it's a different element, and if that is the case, we'll just return false, which means the board is invalid. If all these 3 checks are passed, then our board is valid, so we'll return true in that case. So this function will run for every element, every number on this board, and then if everything is successful, then the true will be returned from the main function. So let's try to run this. Hopefully there are no compilation issues. Hopefully there are no logical issues as well. Oops, where is it? I found some error. Oh, I forgot in. My bad. Yeah. Let's try to run it again. Yeah, it got accepted. Nice. Let's try to submit our code. Yeah, it worked. So yeah, that's a very interesting problem again. This part was a little trickier. I hope you understood how you can solve this problem. So stay tuned for more problems like this. I'll see you in the next one. Bye.